take a look at some tree diagrams. So Lizzie is attempting 2 questions on a test. The probability she gets any exam question correct is 2/3. Correct. Create a tree diagram. So you have your first question right, your first question wrong, and then you could have right, wrong, right, wrong. So then our probabilities, so it would be 2/3 and then 1/3. 2/3, 1/3, 2/3, 1/3. What is the probability that she will only get one of them correct? So if we wanted to highlight these paths here, we could say, so 2 rights in a row. 2 times 2 is 4 ninths. A right and then a wrong. That would be 2 ninths. This path is a wrong and then a right. We have 2 ninths. And then a wrong and a wrong. We have 1 ninth. So what is the probability to show you will only get one of them correct? So that would be right, wrong, or she could get wrong, right, or right, wrong. So if we add those together, we have 4 ninths. What is the probability to show you will get at least one correct? So that's right, right, plus right, wrong, plus wrong, right. And if we add those together, 4, 5, 6, 7, we have 8 ninths. So the next one here, when Laura and Michelle play hockey, the probability that Laura scores is 1/3 and Michelle scores is half. Draw a tree diagram. So we could say Laura scores, Laura no. And then we could have Michelle scores, Michelle no. Michelle scores, Michelle no. And then we have Laura scores is 1/3, so 1/3, 2/3. And then each of these would be half, because half the time Michelle scores. Then find the probability that neither scores. So neither scores would be a no and a no. So 2/3 times 1/2 is 2/6 or 1/3. There are an equal number of boys and girls in a school, and it is known that 1/10 of the boys and 1/10 of the girls walk to school every day. 1/3 of the boys and 1/2 of the girls get a ride. The rest come by bus. Find the proportion of school population that are girls who ride their bus. So, I'm going to draw this way. So a girl and a boy, and it's equal numbers. So here's our tree diagram with half. So how could you come to school? You could bus, walk, or get a ride. So you could bus, walk, or get a ride. It is known 1/10 of the boys and 1/10 of the girls walk. So walk 1/10. This is really messy and not big enough. I apologize. And walk here 1/10. Also 1/3 of the boys and half the girls get a ride. The boys 1/3. And what did it say? Half the girls get a ride. So now we have to figure out that other branch, the bus. Well, let's see. Each branch has to add up to 1. So if we do a little math here on the side, what is 1/10 plus 1/2? So that's 6/10. So that means 4/10 have to take a bus. And if we look at the branches here, we have 1/10 plus 1/3. So if this is over 30, we got 3/30ths plus 10/30ths. So that's 13/30ths there. So that means 17/30ths have to take the bus. So the school population that are girls that ride the bus. So that would be half that you're girls times 4/10 that you ride the bus. So that would be 4/20. Find the proportion of schools that arrive by bus. So that is our girls on the bus. So our girls, and then they're the bus. Plus we have to add our boys that ride the bus. So boys times 17/30. And if we did this on a calculator, or we could find a common denominator, we'd find that this is 29/60. So the next one here, the probability of a day being windy is 0.6. If it is windy, the probability of rain is 0.4. If it is not windy, the probability of rain is 0.2. So we could have wind and no wind. So 0.6 and 0.4. And then we have rain, no rain. Rain, no rain. If it is not windy, the probability of rain is 0.2. So this would have to be 0.2, which means down here is 0.8. If it is windy, the probability of rain is 0.4. So we got 0.4 and 0.6. So letter A. What is the probability of a given day being rainy? So that would be wind and rain, or no wind and rain. So 0.6 times 0.4 plus 0.4 times 0.2. So 0.24 plus 0.16. Oh, that's 0.08. Sorry, can't multiply here. So that's 0.32. Letter B, what is the probability of 2 successive days not being rainy? So let's see, what is our not rainy? So that would be wind and no rain. So that line is 0.36. No wind and no rain. So that is 0.32. So for it not to be rainy, if we add those together, we have 0.68. So 2 days in a row would be 0.68 times 0.68, 0.4629. The next page here. 3 cards are drawn at random from a pack of cards. Each card is not replaced. Find the probability of facing 3 face cards. So 3 face cards, so Jack, Queen, and King. So 12 out of 52 are face cards. We don't replace it, so that means there's 11 out of 51 times 10 out of 50, which gives us a grand total of 11 out of 1,105. Two face cards. So you're drawing 3 cards. So what could we draw? We could draw face, face, no, or face, no, face, or no, face, face. So face, face, no. 12 out of 52, 11 out of 51. Well, how many cards are not face cards? So there's 40 left. Plus a face card, 12 out of 52, 40 out of 51, 11 out of 50. Plus no face, so 40 out of 52, 12 out of 51, 11 out of 50. And then you could add those together. In a bag, there are 4 red, 3 green, and 2 yellow balls. A ball is chosen at random and not replaced. A second ball is then chosen. Find the probability that they're both green. So 4, 5, 6, 7, there's 9 total. So 9, there's 3 green. You draw again, 2 out of 8. So we have 6 out of 72. The balls are the same color, so we could draw a red and a red, a yellow and a yellow, or a green and a green. So red and a red, 4/9 times 3/8, plus a yellow, 2/9 times 1/8, plus 3/9 times 2/8. And if we add these together, we would have, let's see, 12, 13, 14 plus 6, 20 out of 72. Neither ball is red, so we could draw a green, green, yellow, yellow, or green, yellow, or yellow, green. So if we did this, 3/9 times 2/8 plus yellow, 2/9 times 1/8 plus 3/9 times 2/8 plus yellow, 2/9 times 3/8. Let's see, 72 on the bottom. 3 times 2 is 6, plus 2 is 8, plus 6 is 14, plus 6 is 20 out of 72. At least one ball is yellow. So if we list out those choices, yellow, yellow, there's a lot of them here. Yellow, green, green, yellow, red, yellow, or yellow, red. And then we'd have to do all of those. Okay, the next one. 4 balls are drawn at random, one after the other without replacement. From a bag containing the following, find the probability that you draw one of each color. So, there's lots of different orders here. So let's see if you were to draw red, blue, orange, and purple. So your red, 5 out of 5, 9, 10, 11, 12, 13, 14. Times a blue, 4 out of 13. Plus an orange, 3 out of 12 times, sorry. Plus a purple, 2 out of 11. So a grand total of 5 over 1001. But we could rearrange these because we could do red, blue, purple, orange, red, purple, orange, blue. So we could do all these different arrangements. And well, how many are there? So there's 4 colors we could draw first, then 3, then 2, then 1. So there's a total of 24 different arrangements. Oops, that's a times. I don't know why I put plus. But they each have the same probability. So if we multiply this times 24, we have 120 over 101. Okay. Billy answers on average 5 problems correctly out of 7. Natasha's average is 5 out of 9. They both attempt the same problem. What is the probability at least one of the students answers the question correctly? So we could have how should we do this? Make sense of this. So we could have Bill right, Natasha right, or we could have them both right. We could have Bill right and Natasha wrong, or Bill wrong and Natasha right. So Bill right, Natasha right. We would have 5/7 times 5/9 plus Bill right, 5/7. Natasha's wrong would be 4/9 plus Bill right, 5, nope, he's wrong, sorry on that one. So 2/7 times 5/9. And if we add these together, our denominator is 63. We'd have 25 plus 20 plus 10. So we got 55 out of 63.